This is a research collaborative effort where we have received contributions from IITM, IMD, CDAC, etc. And moving on with the next slide. Uh, Agricultural burning is actually most of the people in world, they are mainly focused on forest fires. So globally, it's a hot trending topic nowadays, as we can see in news media and so on. But when it comes to South Asia, I want to draw everybody's attention to agricultural burning because actually, sorry, to agricultural burning, and this is because farmers, they are burning the crop residue so that they can go for the next planting, for the next round of crops. And basically here I'm talking about paddy stubble burning so that they can produce wheat for the next planting season. As Pallavi ma'am.
You're not showing the presentation.
Oh,
So yeah, so people in today's world, they are more, mainly focusing on a global scale, focusing on wildlife fires or forest fires. But when it comes to South Asia, the major concern towards the degradation of the air quality is majorly one of the factors affecting is due to crop residue burning. So recent stats also support that there has been a contribution of 30 to 40% of the agricultural burning activities towards degrading the air quality of Delhi and NCR regions. So what exactly farmers are doing, as it is a manual practice of emitting the pollutants into the air, so they are clearing the fields for the next round of crops. And basically here I'm trying to tell about stubble burning, where they are burning their agricultural fields so that they can sow for the next planting season, that is for the wheat crop. And since there is a very less time span, so they find this means as a quicker and cheaper means to sow. So, but it does do have detrimental impacts to the atmosphere as it releases a large number of pollutants when the biomass burning events takes place, like particulate matter or carbon monoxide or methane, they get emitted out into the atmosphere. So when I'm talking about stubble burning, the main states which highlight this issue are the northwestern parts of India, that is Punjab, Haryana, UP and Bihar. But in our study, we focus mainly on Punjab as well as Haryana states, like Pallavi ma'am has also told in her presentation that how the crop residue burning has its own issues as well as challenges. And yeah, so we'll try to see how, on next slide. So we'll try to see how the deteriorating air quality in Delhi, it is one of the major reasons due to crop residue burning. But there are several methods so that we can detect these kind of episodes in India. One such method is because of satellite-based detection techniques. But if we also opt for these kind of techniques, they do have their uncertainties in their own predictions. And we in our research work has tried to address these uncertainties and to quantify the emissions. So, yeah, next slide, please. So the research objectives of my research, of my current work so far are, I've tried to estimate the emissions for the year. Basically, I've taken the year 2022 as a reference study. And this crop burning episodes are mostly detected during the winter season. And I have tried to do the comparative analysis of these kinds of burning events from two different satellite data sets, that is from VRS as well as from Sentinel-2. And I've tried to estimate the emissions from these two different data sets, and I've tried to compare the emissions generated from these kind of data sets and what all uncertainties do we really address while studying these. So, next slide. Okay, so this is actually a study area where we have tried to focus majorly on the shaded ones are the regions where I have tried to focus and study the majorly the CRB episodes. And yeah, next slide. Okay, so here we have adopted a particular methodology to carry out our study. So the first, we have used here a coupled methodology, which I don't know in India so far it has been done, but we are trying to bring this to a novelty purpose. And here we have taken the agricultural statistics from crop statistics report generated by the government of India, where we have the records of crop production, yield, and particular crops over different regions of the world, different regions of our country for the year 2022. And then we have two satellite data sets. One is at a resolution of 10 meters, and which we have taken from ESA. The another is of VRS fire count, where we have taken the active fire count information at 375 resolutions. So satellite imagery has been taken from two different time periods. One is at the time of fully harvesting, that is from August, September, October. And then we have the VRS fire count data, that is from October to November for the year 2022. After we have come up with an algorithm where we have tried to generate the emissions. Suppose for any kind of pollutant K, the emission value will be given by the summation of CP, RC, FDM, F burnt, where RC stands for residue to crop ratio. CP is actually the annual production of any particular district J. Then we have the dry matter fraction of crop. Then F burnt is the fraction of crop residue, which is actually burnt. Then we have the burn efficiency, or how much fraction of the crop residue is oxidized. And then we have the emission factors for pollutant K. So among all the parameters over here, we have taken this from literature sources, but EFK is the one which is showing variations over here, and CP it is the annual crop production which we have generated from our own statistics. So yes, moving on to the next slide. So this is actually a diagrammatic representation of the maps we have generated so far. So with the help of remote sensing tools and GIS, we have tried to come up by using the satellite images. We have pre-processed and performed land use land cover classification of those satellite images. At 10 meters resolution, the first two figures are at 10 meters resolution, which tells that the first figure, it tells about the map which shows that at the time of fully harvesting of the crops, how much area of agricultural land was really available. And so this was for the period before the crops are being set to cut or being harvested. And then we have the burnt area map, which tells us the red patches here defines what our areas of Punjab and Haryana there have been burnt areas being detected using Sentinel-2. Then the last map shows the VRS fire count area where we have taken from firm's site. And so it tells us that most of the parts of Haryana are being missed by VRS, which Sentinel-2 has captured so far in by the resolution of 10 meters. So our estimate states that there has been 23,000 kilometers square of area which was burnt in the year 2022 in Punjab and Haryana, while VRS has captured only 6,000 kilometers square area. So there is an underestimation of 60 to 70% of the burnt area which VRS has failed so far. So I just wanted to bring into the comparative analysis of these two burnt areas which has been captured by two different data sets. And yeah, so moving on to the next slide. Here we have a comparative analysis again, where we have tried to see the crop production, which we got from the governmental statistics, from agricultural stats reports from Government of India. And then there is another difference of crop production, which we have estimated using our parameters of burnt area using the Sentinel-2 satellite imagery. So the yellow line, it tells us about the yield values, which we have got again from crop stats report. And then the green bars, it tells us the satellite detected burnt area, which we have performed using supervised classification. So in both Punjab as well as in Haryana, we could see that the blue and red bars, they are in moderate to good correlation with one another. So it actually gives us a green signal that we are going towards a correct methodology while performing this estimation of emissions. So then another slide, it tells us another slide. So there is this another slide which tells us about the percentage of the crop production that is actually burnt in both the states of Punjab as well as Haryana in a district-wise manner. So majorly, as we also know that Punjab usually practices more burning activities as compared to Haryana, which is clearly visible over here. And our stats estimated that 59% of the crop produced land has been burnt in Punjab, whereas 38 to 39% of land has been burnt in Haryana. So then the next slide, it tells us about, okay, so this is actually a district-wise emission estimates. So for Punjab, we have done as well as for Haryana, and but here I'm showing only one state. I just wanted to draw attention over here is that when we see all the pollutants concentrations with respect to their with respect to different districts of Punjab, likewise for pollutants like PM 2.5 CO or OC or BCE or NH3 like that. So we can so the blue ones are the ones which the emissions which has been detected by Sentinel-2, and the orange or yellow ones are the ones emissions which has been detected by VRS. And so we can see that clearly there is a variation in the the values of the concentration of different pollutants for all the districts. So this might be due to different kind of agricultural practices that they are following, or maybe because of soil moisture properties, or what is the property of the soil over there, what is the moisture content available at the time of burning in the stubble, and what kind of commercial activities do they really practice at the time of stubble burning, and so on. Also, one such fact is that VRS usually has a low concentration of pollutants as compared to Sentinel-2. So this might be due to several factors affecting, like how VRS has detected the fire count events. So it only captures the short time fire count events because it has a daily revisit time. And also it has a coarser resolution of 375 meters, whereas Sentinel with a higher resolution has was able to capture more burnt area, and therefore we could see that more emissions have been generated in the case of Sentinel-2. So next slide. Okay, so here, whatever emissions we have generated so far in our study, we have tried to compare those emissions with other studies as well. And but by adopting methodologies from their respective studies, but incorporating our data into their methodologies. And what we could see is that there are several factors affecting the emissions generation for any kind of district or any kind of state which we wanted to study. So for instance, Sahu et al. From 2021, we could see that it has the highest emissions recorded for all the major pollutants so far. And our studies are somewhat show a relation to that study. So the major reason behind will be the emission factors which they have taken. So since we have regional wise emission factors, but still there is a need to identify or to understand the uncertainties regarding the emission factors. Since we are working on the same regions, but still the parameters and emission factors, they are the minor ones, but they do play a key role in estimating the emissions in a variable scale. So the second plot, second panel plot, it tells us about the variability in the emission estimates, which can be quantified using the ratio of the maximum and minimum values from different studies which we have adopted so far. And clearly, ammonia, sulfur dioxide, and carbon monoxide, they have the emissions which are really uncertain as compared to other pollutants in Punjab. However, in Haryana, SO2 emissions has been pronounced very, very high. So it indicates that there has been a difficulty in finding out the emissions of sulfur dioxide from agricultural burning. And so after that, I wanted to draw some of the conclusions from our research work so far. Yeah. So, since MODIS has not been currently in use, but we people are relying on VRS file count data. So, but we have seen from our studies, since VRS even at resolution of 375 meters, it couldn't capture most of the areas of Haryana, which Sentinel-2 has captured so far, and because mainly of the resolutions, and we need to come up with certain signature, and Sentinel-2 can also detect the residual signatures of the crop residue events where VRS is short-lived and it captures the real-time fires occurring over a particular region. But even if you are working with Sentinel-2, there are certain discrepancies or uncertainties coming up with. Likewise, if we wanted to look for the emissions or the concentration of the emissions coming out from those, likewise, the values of sulfur dioxide and carbon monoxide, likewise, we have seen in the previous slides. So, Yeah, so we need to come up with certain technologies or certain kind of data sets which also leads to, clearing of the more uncertainties in detection of the fires, whether it can lead to more clear sky images or we can have cloud filtering techniques as well. And instead of relying on one data sets, I think that we should rely on more data sets as well so that more accuracy can be adopted for better air quality forecasting purposes and this will also help in further policy making. So, yeah, thank you so much for your attention. Yes.